Hi everyone, it's Randy. Okay, I guess I lied when I said it was my last video a few months ago. I'm back to give an update on my Vic-II Kawari project. This video is mostly me rambling about stuff and not particularly organized around one thing. Some of this comes from the discussions on the Discord channel over the last few months, and some of it is just me blasting out updates, so feel free to join the discussion and follow along there. The link will be in the video description below. So first of all, thanks to everyone who purchased a board. Over 450 boards were sold, combined mini and large versions from the first two batches. There was an initial small batch of 50 and then a larger batch later. Thanks to everyone who supported this project, and to those who had some initial issues, thank you for your patience as we worked out some problems with the initial firmware, but we'll get into that later. I placed another order to pick up tail end of demand. Both VGP and myself have them in hand, and we just need to program and test them. I will open my Shopify site for North America, Australia, New Zealand orders next week. Watch the Discord channel for an announcement. So just like last time, VGP will handle EU, UK distribution, but they also ship worldwide. Most of the devices went to VGP this time, but I have a few here, and I will likely shut down my Shopify site after they're done. That's because it takes a lot of time to program, test, package, and ship, and it's just not something I really want to continue doing, so this is likely the last run for my Shopify site. VGP will probably also be available next week. If it turns out there's more demand after that, then I think I'll give the pre-order system another try. So whoever wants to get one will be able to get one. Okay, where's the project at? Well, it turned out that there were way more permutations of hardware that the community was able to try out that I never could, and that revealed some issues with the initial firmware. There were new motherboard builds, like the Melius board, the Evo 64, neither of which I had. There were a variety of static RAM modules, like DIY Chris, Saruman, CB Metro, and then the Melius board and the Evo 64 board also had static RAM. The first firmware version did not play well with the static RAM types, so initially I put out a static RAM version of the firmware to deal with that temporarily, but now there's a single firmware that will operate with both DRAM and static RAM. I didn't have all these combinations to test with when I was developing, so what I've done is try to bring in more longboard revisions and use a reasonable combination of different RAM configurations to have a wider range of hardware to test. Okay, this is my new testing setup. Over here is a 250407 board with 150 nanosecond DRAM. This is where I do most of my testing. And then over here is a 250466 board that I put together myself. I test both DRAM and static RAM. This has a Saruman board. There's also a JPLA plugged into there, but I can also put in a genuine PLA. This one is a 250425 board, again with DRAM 150 nanoseconds, and that's pretty standard. Over here we have a 326298 board. This is one of the very early models. It doesn't have the separate Chroma Luma signal on the video port. It only has composite out. This one has DRAM at 200 nanoseconds, I believe. And then finally we have another 250407 board with, this is where I test the static RAM modules. This one has a DIY Chris SRAM. Sorry, no, this is I think CB Metro. This is the DIY Chris board. And I can also put in 150 nanosecond DRAM into this one. And then this is another 250407 board I have that I sometimes use. It has missing CIA chips I have to swap from another board. For specialty cartridges, I tried the Kung Fu Flash cartridge. I also have Fast Load cartridge, Super Zaxxon, and this is a Wi-Fi modem cartridge, and this is a final cartridge without the case. Initially, I had advertised this as something that would replace Vic-IIs in bread bins, but I think I should have focused on the motherboard revision numbers, because some of these revisions actually did show up in 64C shells, but for the most part long boards are compatible. So that's the 250407, 250425, 466. the older 326298, and then I don't have one, but that KU14194HB, that should also work, and then of course the Evo 64 and Melius are also supported. What doesn't work is the 250469, that's the short board that showed up in 64C shells, and I suspect that there is a super PLA issue. It has different expectations with respect to timing, so there are glitches. It does work inside there for the most part, but you're going to get glitches, and it's not it's not a motherboard that takes the 6567 and 6569 chips. They use the 8562 and 8565 chips, which are slightly different, and this project was meant always to replace the 6567 and 6569 chips. And the other reason I don't recommend for this board is closing the 64C shell is quite difficult, especially with a large board. I think there are probably ways to do it with the small board, or it's a little easier, but I think what's really required for this motherboard revision is a separate firmware, and I suspect it's possible with a dedicated firmware to doing this, but it's not something that I'm actively looking into. So if anybody wants to tackle this, send me an email and we can talk about what that would entail. Okay, so I'm just going to go through some firmware updates. The latest will be version 1.16. So the first issue that I fixed in version 1.14 was that the composite video was shifted to the left a little bit, and a user by the name of Mathop37 on the Discord channel posted the correct values, and then I made those changes, so everything should be identical to the original chips now. There was also a vertical blanking issue with the composite out, and I made things a little closer to NTSC and PAL spec. So the hammerhead pattern that you'll see if you adjust the V-hold on your display, it looks a little better now. There's still some horizontal tearing at the top left corner, but that also appears on the real chips too. Similar to that, the analog RGB video was also shifted to the left too much, so that was fixed. I also added this option called NTSC 50, and this is a feature suggested by Adrian Black. It's also available on the Ultimate 64. What it does is it lets you use use monitors that can sync to 50 Hertz, but they don't understand PAL color encoding. And it lets you get a color image by using the NTSC color encoding standard with a 50 Hertz display. So what that means is you can use this on a 1084, 1702, or 1802 monitor and get a color PAL display or a color PAL machine without having to use an expensive PVM. And so this is what that looks like. If you hook this up to say 1084, you'll see this rolling, and then you just use the V-hold knob to stop the rolling. Then of course you're getting a black and white image. Just turn on NTSC 50 and you should get a color display. And so this might look a little odd to PAL users because it's NTSC encoding, but I'll just run a game here to see some colors, and then I'll adjust the colors a bit to make them pop out a bit more. Sorry for the flashing, but that's just the camera. Okay, there was also an issue with the large board. The dot clock signal was not showing up on the clock pin on the RGB header. That's only for people who were interested in feeding the dot clock signal back into the motherboard. It's not something that most people would be worried about anyway. Number 6, I improved the DVI signal quality a bit. This is still hit and miss. Some monitors just don't like the signal. This latest update syncs much more consistently for me on my monitors. There was one user who had this weird zigzag pattern. It didn't like the odd width resolutions, and that's the result. And I could not fix that issue. I think that's just the monitor freaking out about the odd resolution widths. Then I did find a couple Blitter Bugs while I was working on the emulator, and those were fixed in version 1.16, only relevant if you're trying to use the extended features. I also lengthened the color burst signal after I noticed that the color burst signal on the original chip was longer than what the spec actually said, so I made mine match as well. Like I mentioned before, there's a single firmware for both static and dynamic RAM that's available in 114 or above. So for something like the Evo 64, you will need at least 114 or above. And then finally, there was a sprite collision bug, and someone noticed this in Pitfall 2, the balloon catch. No matter how hard you tried, you could not jump and catch that balloon because the collision was not registering. So that was fixed in I think 114 or above. There were also color palette updates, thanks to Adrian from Adrian's Digital Basement and Mark from the Retro channel for taking the time to create better default palettes for Luma and Chroma video output. I knew I wasn't going to get it right, and that's why they're configurable. I'll just show you briefly what that looks like. So if you run Cont'd and now you press J, you get this option here to set one of the presets. So that one was from Adrian Black, and this one is from Mark. So there are there's one for each of the 4 chips available, but you can either do them individually like I did here, or you can reset your device so that the config will detect that your device needs to be set, and it will do all the chips all at once. This is a quirk to be aware of. If the extended features are enabled, like if you, for example, run the config program or any of the editors like the RGB editor, comp editor, or even demos, that enables the extended registers, and programs like Super Mario Brothers will enable turbo option. It's because of this register conflict. It basically thinks it's a C128 because the Kawari opens up some registers that are normally inaccessible by a 64, but then if they're available, then the software might think that it's a Commodore 128, and the fast mode might be available. And so if you ever run Super Mario Brothers after a soft reset where you had activated the extended registers, it'll say turbo is available, but that's not true. And if you were to try and play it, it would actually be slower. So just keep that in mind. It's just best to cold boot if you have that issue. So there is an emulator now. This is basically a fork of Vice with the extended features implemented. That's the new high-res modes, 160 200, 320 by 200, 640 by 200. The 80 column mode, the DMA functions like the blitter, the copy fill, math operations, and then the palette changes. So the Kawari Inside demo runs now, and you have to compile this yourself. I don't provide builds, but it's just available on GitHub. And let's take a look at what that looks like. So this is what the ball looks like, the ball program, which with the color cycling. This is only captured at something like 30 frames a second, so it's not going to look smooth, but it looks pretty good on your desktop. And just going to go and CD into one of the tests. So these are tests that I wrote to exercise the blitter. This is where I noticed the blitter bugs. It mostly affected 640 by 200 mode. The right edge was not was sometimes getting clobbered. So these programs are just I'm aware of what they ought to look like, and they just test some of the features of the blitter. And this is Racer. This is a 80 column version of the 8-bit show and tell Racer program. So first we activate the 80 column mode, and then we have to load this this other wedge, which provides BASIC with some quick routines to be able to change some of these 80 column screen locations. So then we load the BASIC program. Here it is. And so this is basically the same 8-bit show and tell 80 Racer app program, but extended to 80 columns. And you use the 4 and 6 key to move your guy left and right. Exciting. So yeah, the emulator's there if you're interested in exploring the extended features. And let me know if there are any issues or bugs you find, and I'll try to address those. Okay, so in version 1.16, there's some new DMA behavior, and there are two things I regretted in the initial firmware. Number one, you had to poll for DMA completion. And that's kind of a waste of CPU cycles. And then number two, you had to copy, or you couldn't copy into extended registers. So, for example, the palette definition registers. So polling versus IRQ. So when you start a DMA operation like copy, fill, blitter, etc., the CPU had to check a register to know if the operation was complete. But there's a better way. If you look at registers D019 and D01A, on the Vic, you'll see that there are unused bits in the middle there, and what I did is I added my own IRQ status and control bit for the DMA functions. So if you're unaware of how this works, there's a control register where you enable or disable certain IRQ operations, or sorry, certain notifications of events like raster interrupts, sprite to background collision interrupts, sprite to sprite interrupts, and then the light pen. And so what I did is I added my own status and control bit for DMA. And what that does is the Vic-II will raise an interrupt. It lowers the IRQ line so that the CPU executes the IRQ vector, and then it saves you from having to waste CPU time polling, where you could do other things, more useful things with your CPU, and you can chain a bunch of DMA operations together without wasting CPU cycles. And then the second thing was being able to DMA copy into the extended registers area, and this is mostly useful for changing the palette quickly. So for example, we have only 16 colors, but we can define what those 16 colors are using 3 RGB values. But it costs way too many CPU cycles to change all 16 colors. That would be 48 register changes. So a better way would be to use DMA copy from one region of VRAM into the extended registers, and that only takes 6 cycles to change the palette, and you can do it without the CPU, other than the instructions to initiate the DMA copy, and that can be done off screen too. So I thought of an example of how this would be useful, and I thought, well, what would happen if you changed the palette every raster line? So I gave this a shot. I wrote a program to generate, to take just an arbitrary JPEG and split it up line by line, and then run every line through a program called Image Magic, which picks the best match or best palette, and you can limit how many colors it matches to. And so I said, okay, for every line of this image, give me the best 16 color palette. And then what I did is I wrote a program to swap in the palette every raster line. So that's 200 distinct palettes. That takes about 12K of data, and then the image itself is 32K, which is just a regular indexed to 16 color image. And then it changes so it swaps that new palette in for every raster line, and this is what that looks like. So this is a bit overexposed, but this is what that ends up looking like. If we take a look here, so this is every line you're seeing here is a unique 16 color palette, and you just get a wider range of colors. And you can see where the transition is happening because the background color is changing on the borders. So here's what the source of that, or some of the source of that, would look like. So this part here, this is basically repeated 200 times, and all it does is it loads the high and low byte of the next palette and then initiates the DMA transfer. And you can see there's actually more cycles than you need to do that, because I have a bunch of no ops in here to spread this over 65 cycles. So what you saw there was for PAL, but it could be also done for NTSC as well. And this happens after a raster interrupt on line 50, and this is repeated, and it basically chases the raster line down for 200 rows, and then repeats for every frame. So I thought that looked pretty decent, and that's a good example of what you might be able to do with being able to DMA copy into the extended registers area. Next up, I think I'm going to write a game, and I'm going to take advantage of these extended features for the Kawari board, and I think I will probably video blog this as I design it and develop it. I'll build out some libraries for other people who are interested, and yeah, we'll see how it goes. So yeah, that's it for now. Thanks for your support, and I will see you again soon.